Good
afternoon, all. Good afternoon. Now, I'll proceed to the class. Yesterday, you have done problems of chapter 2. My planning, I'll start the new chapter today. That is your linear equations. Linear equation in two variable. I'll start today the new chapter. So, be ready. I will start new chapter today. I may be visible or not, audible or not. Have patience and stay with me. You'll follow my instruction and proceed side by side. You'll solve all the problems. Now the number is only 11. So far as number of students is concerned, only 11 students are present till now. I expect your numbers should more than 30. Very few are having some problems, but you all should attend the class. Now the number is 12. Okay, till then I will start the class. Okay. Our new chapter, that is chapter 3, pair of linear equations in two variables. Pair of linear equations in two variables. So, you can write linear equations. Linear equations. If a linear equation is given, you can draw graph of the equation. I am writing now some equations. You will tell me the graph. If you like the graph, you can tell me the equations. But now I will write equation. I will tell the graph. At the same time, I will draw the graph and write the equation. Just I want to cover the portion completed in your previous class. I mean in standard 9. Graphical representation of a line. Straight line is represented by a linear equation. Ax plus by equal to c. This represents a straight line equal to 0. This line always passes through origin. Remember one point. When constant term is 0, when c is 0, the graph of the line passes through the origin. This line passes through the origin. If b equal to 0, then our equation became ax equal to c. Then you can write ax equal to c by a. X equal to c by a is same as x equal to x1 or x equal to x0 or x equal to constant. Constant. Here, you know, x equal to 0 represents equation is x equal to 0. Its graph is y-axis. This x equal to c by a represents a straight line parallel to y-axis. Perpendicular. If 0, y-axis itself is and parallel to y-axis. if a equal to if a equal to 0, then our equation became by equal to c, or y equal to c by b. Y equal to c by b. You know, graph of y equal to 0 is x-axis. Y equal to 0 is x-axis. When equation is of this form, y equal to c by b, I mean y equal to constant. Y equal to 0 equal to x-axis. If it is positive, below x-axis. Now I will show this thing graphically. First, I repeat this thing. Basic concepts. Ax by equal to c is your linear equation. Here a, b, c, these are coefficients or constants, all are real numbers. X and y are called variables. So it represents a linear equation in two variables. Variables are x and y. If constant term c0, equation became ax plus by, all such lines passes through origin. Then if y is positive, that is a line parallel to x-axis, above x-axis. If y equal to minus something, the line one equation I'm writing, x equal to y. On your copy, you draw the graph of this one. X equal to y, question number 1. On the same paper, same graph, rough diagram only. Graph paper not required. On your rough copy, you draw graph of. Now, use your rough sketch. Just I want to know what type of line are obtained here. Draw, draw these lines on your rough sketch. I want to discuss these lines. Then I'll proceed to the book. First, basic concept should be clear. Concept should be clear. You draw graph of these 4 lines. These are the equations to draw the graph. First, this is your y-axis, x-axis. Horizontal line is your x-axis. This is your y-axis. Y dash. This is your x dash, x. This is your origin. O is your origin. Both are perpendicular to each other. This is your origin. Point of intersection of x-axis and y-axis. These things are known to you. Now, you have to draw these 4 lines on this graph. You draw first. I will check it. You will check your answer with me. First line, x equal to y. First line is x equal to y. X equal to y is the line passing through origin. Passing through origin. This is a straight line. Passing through origin, equally inclined to the coordinate axis. I mean, angle between line and x-axis, this angle is same as this line, this angle. These two angles are equal. Equally inclined and passes through origin. Other form, this one can be written as x minus y equal to 0. Same. X equal to 0 is same as x minus y equal to 0. It is also same as y minus x equal to 0. Same graph. Similarly, x equal to 5. Suppose this point is 5. Then this is the line. Throughout this line, x coordinate is 5. So, this is a line passing through the point 5, 0, 5, 0 and parallel to y-axis. This line parallel to y-axis, perpendicular to x-axis, parallel to y-axis, passing through the point 5, 0. This is your graph line. Then y equal to minus 3. Y equal to minus 3 is a line parallel to x-axis, below x-axis, passing through the point 0, minus 3. 0, minus 3. This line parallel to x-axis, below x-axis, passing through the point 0, minus 3, x coordinate 0 and y coordinate is minus 3. Throughout this line, y coordinate is minus 3. So name of this line is, or equation of this line is y equal to minus 3. Y equal to minus 3. Then fourth one, if we take x0, normally you are using table, make the table x, y. If x0, y will be 5. If y0, then x will be 5. Now the 2.05 and 50. If we look at these 2 points, here is 50, here is 0.5, this point is 0.5, was 0.5, this point 0.550. Now you are getting the line. You are getting the line. This line is passing through the point 0.5 and 50. Okay, this is your graph. These are some basic concepts related to graph. If a point is given, how can you locate? You know how to locate the points. You can draw straight lines when linear equations are given in your previous class. I mean in standard 9, you know this thing. Yes, some of you are writing, nothing is visible. Give emphasis to audibility, whether I'm audible or not. If I'm audible, you follow the audio and try to draw by your own. Keep your copy with you, draw the line segments or lines, and you can get it. Now I will proceed to your topic. In this chapter, linear equation, first you will draw. First you have to frame the equations. After framing the equations, then you will put on the graph, then you will solve. There are two types of solutions. First is your graphical solution, then algebraic solutions. Graphical solutions and algebraic solutions. Graphical solutions. Suppose two linear equations are given. Draw the two lines on the graph paper. That two lines may intersect each other, may coincident each other, may be parallel to each other. If they intersect each other at a point, from that point you will get your solution. From that point you will get your solution. Suppose two lines intersect each other at a point 4, 5. At a point 4, 5. 4 is x coordinate, 5 is y coordinate. I mean x coordinate of the point is value of x, y coordinate of the point of intersection is value of y. If two linear equations are given, draw the graph of these two lines on the same graph paper. Same plane. See the point of intersection. From the point of intersection, in this chapter, question will be given. First of all, you have to frame the equation using the variables x and y. Take x as one of the variable, then takes y as another variable. Frame the equations, then draw the equations on the graph paper. Then the common solution obtained give you the solution for x and y. Now we'll proceed to your book. Particular problem will be discussed. First, you see how the equations are framed. See now, here one example is given. You all see first example, then I will come back again the nature of the graph. Example 1, page number 41. You all open the book, page 41, read twice example 1. Let us take the example given in section 3.1. In 3.1, Akira goes to a fair with rupees 20 and wants to have rides on the giant wheel and play hopla. Do you know these two games? Giant wheel and play hopla. Represent this situation graphically. Represent the situation graphically means you have to frame the equation. By taking x and y, you have to frame the equation. Here, our equation is coming y equal to 1 by 2x. By cross multiplication, 2y equal to x. Hence, x minus 2y equal to 0. First equation. Then second equation is coming 3x plus 4y equal to 20. X minus 2y equal to 0. 3x plus equations are now. Then how can you draw the graph? Two equations. Now you draw roughly the graph of these two equations. First equation is x minus 2y equal to 0. It may not visible, but you follow the instruction and you draw by your own whether it is discussed in standard 9 or not. You tell me. X minus 2y. X minus 2y equal to 0. It is a linear equation. Make the table, put the points on the graph and draw the solution. Draw the graph. X minus 2y equal to 0. One equation. Second equation is 3x plus 4y equal to 20. Draw these two equations on the same graph paper. You will see the two lines meet each other at a point. That point, as it is one example here, you see the table is given, table 3.1. For first equation, when x0, y is also 0, if you put x0, y is also coming 0, first point. If you put x equal to 2, then y is coming 1, 2 points. Similarly, that second also given, x and y, make the table, locate the points on the graph paper and you will get graph. See the graph in page 42. Open your book, page 42. See the graph. You observe the two graphs. Graph of this equation, x minus 2y equal 0, as c is 0, as a constant term is 0, it passes through origin. And second line is done here. Now, the two lines intersect each other at the point 4, 2. 4, 2. These two lines meet each other at the point 4, 2. It means x equal to 4 and y equal to 2. This is the solution. X equal to 4 and y equal to 2. That's the solution. X equal to 4 and y equal to 2. Next, listen to some basic concepts. If two equations are given and you are drawing the graph, what are the nature of the graph? That two lines may intersect each other, may coincident to each other, may be parallel to each other. Two lines on a plane. Three options. They intersect each other, they may parallel each other, or they may coincident to each other. If two lines are drawn, they may intersect each other at one point. Another case, they may draw one upon another. Coincident lines, one upon another. Coincident lines. And third case, they may be parallel lines. This is the case 1, suppose, case 2, and this is the case 3. Two lines are parallel here. Here two lines coincident to each other, one line upon another line. And here they intersect each other. In this case, you are having exactly one solution, that is called unique solution. This case, infinitely many solution. Infinitely many solution. This case, it has no solution. If two lines are parallel, suppose two equations are given to you, the graphs are done. You observe one thing, they are parallel to each other. In that case, your conclusion is the system has no solution. If a graph parallel to each other, then the system has no solution. If coincident lines, all the lines are occurring one upon another, two equations are given, you are getting the same line, same graph. That means infinitely many solutions. When two lines intersect each other at one point, from this point you will get the solution. And suppose its x coordinate is x, y coordinate is y, then value of x is this one, value of y is this one. This is your some properties related to graph, graphical representation. Now you see exercise 3.1. Exercise 3.1. Okay, it is not visible. Most of your writing, it is not visible. Okay, am I audible or not? Whether my voice is audible to you or not, that I want. If I am not audible, I will not take the class. Am I audible or not? I expect answer from you all, whether I am audible or not audible. Sometimes it is visible, sometimes it is not visible. Actually, sometimes it is visible and sometimes it is not visible. But whether I am audible or not audible. Actually, powerful web camera is required for clear photograph. Powerful web camera is required. In laptop or in mobile, the camera available is not able to take the photograph of the small letters, the small sentences. Okay. Okay. It is not visible, but my voice is audible so far as your answer is coming on my live chat. Okay. Proceed to exercise 3.1. Exercise 3.1, you read yourself question number 1. I will discuss now all the three problems here. You read first question number 1. Exercise 3.1. Exercise 3.1 and question number 1. Question number 1. This one. It is written, Optab tells his daughter, 7 years ago, I was 7 times as old as you. Where then? Also 3 years from now, I shall be 3 times as old as you will be. This situation is one interesting situation. How can you write this statement algebraically? Express this thing algebraically. Suppose you may take Optab's present age is x. You take in this way. Optab's present age is x and his daughter's age is y, and frame the equation. You will get two equations. Shivasis have already sent the equations. Very good. You take Optab's age is x and his daughter's age is y, present ages. First case, 7 years ago. 7 years ago, Optab's age will be x minus 7. 7 years ago, x minus 7. And daughter's age will be y minus 7. Present age taken as y. 7 years ago means y minus 7 years. Y minus 7. I was 7 times as old as you. It means x minus 7 equal to 7 times y minus 7. This is your equation. X minus 7 equal to 7 into y minus 7. Simplify this one, you will get one equation from the first situation. For second situation, 3 years from now, 3 years from now, or 3 years hence, it means after 3 years. After 3 years, Octave's age will be x plus 3, x plus 3, and daughter's age will be y plus 3. After 3 years, present age is y. After 3 years, this age will be y plus 3, and Octave's age will be x plus 3. At that time, as per the question, I shall be 3 times as old as you will be. I shall be 3 times means x plus 3 is equal to 3 times of y plus 3. Then you simplify, write the two equations in the standard form. I've already got the answer from Shivashis and Subhendu. Subhendu Manti. X minus 7y plus 42 equal 0. X minus 3y equal to 6. You both have written the same answer. Okay, you all check whether you all are correct or wrong. This equation, first equation is x minus 7y equal to 7 into 7, 49. 49. How to draw equation of type? You follow the way you have done equations in standard 9, apply that concept and draw the lines. Here only you have to draw the lines, not to solve. In this exercise, only you have to represent the situation algebraically and graphically, algebraically and geometrically. Graphically or geometrically, the meaning remains same by using graph. Algebraically means you have to show the equations. Now work out 3. Next is question number 3 for you. You do now question number 3. You try first. Question number 3. Exercise 3.1. Question number 3. You solve. If possible, you can show me the result in the live chat. In the live chat, you can show me. I will see here. Yes, Jyotiraditya, you have completed. Chandrasekhar Murmu, Mamta Jana. Very few students are attending the class. Now the number is 17. Now the number is fluctuating. 18 now. Sometimes 19, 16, 15. Today highest is coming till now. It is 20 highest. The peak is coming 20 till now. Now our class is exceeding half an hour. I'll discuss the next one. Your next exercise is equations are given. You have to draw the graph and find the solution. Before that, I will discuss some points regarding the general equations. Okay. Now I will proceed to next exercise. In next exercise, you have to solve graphically. Very good. Most of you are giving the answer. Acha, Sujay, you are writing. Very good. Video may be stopped. Okay. Listen the voice and try to follow. Next, for discussing next exercise, listen some basic concepts. Write down the two equations again. in general form. That general form or in the standard form, you write the two equations. First equation, a1x plus b1y plus c1 equal to 0. Write down second equation, a2x plus b2y plus c2 equal to 0. Two equations are given, two linear equations with the variables a1x plus b1y plus c1 equal 0. Second equation, a2x plus b2y plus c2 equal to 0. Then a1, b1, c1, a2, b2, c2, these are real numbers. Consider the coefficients of x. a1 by a2. Calculate a1 divided by a2. Then calculate b1 by b2. Then calculate c1 by c2. If a1 by a2 is not equal to b1 by b2, if this condition holds, then it is not required. Not required to calculate c1 by c2. From this, we'll conclude that the system has equations, unique solution. The system has unique solution. Graph will intersect at a unique point. If this condition holds, a1 by a2 is not equal to b1 by b2, then the lines intersect each other exactly at one point. X coordinate of that point is value of x, y coordinate of that point is value of y. So a1 by a2 not equal to b1 by b2 give us the conclusion that the system has unique solution and graph intersect exactly at one point. If this is not equal, suppose a1 is equal to b1. Sorry, a1 by a2 is equal to b1 by b2. Suppose this condition hold. Then c1 by c2 is required. It may be equal, it may not be equal. a1 by a2 equal to b1 by b2 equal to c1 by c2, or a1 by a2 equal to b1 by b2 is not equal to c1 by c2. If this condition holds, then lines are coincident to each other. In this case, you will get to not equal to c1 by c2. Then you will get the two lines are parallel. Two lines never intersect. Such no solution. If solution exists, if solution exists, then the system is called consistent. If solution exists, the system called consistent. If solution does not exist, then the system is inconsistent. The first is a1 by a2 not equal to b1 by b2. This case, and a1 by a2 equal to b1 by b2 equal to c1 by 2. In these two cases, solution exists, so this is your consistent. System is consistent here, but this case, a1 by a2, a1 by a2 equal to b1 by b2 is not equal to c1. The graph of the lines are parallel. In this case, the two lines are parallel to each other. If two lines are parallel to each other, then the system has no solution. It is called inconsistent. Previous to consistent, here it is inconsistent. These are some properties related to linear equation in two variables. Now, in your exercise 3.2, Now proceed to exercise 3.2. Question number 1. Your instruction. Form the pair of linear equation in the following problems and find their solution graphically. Like 3.1, here the graph, then find point of intersection. From point of intersection, you will get x coordinate and y coordinate. X coordinate is value of x, y coordinate is value of y. In question number 2, your instruction is on comparing the ratios a1 by a2, b1 by b2, the following pair of linear equations intersect at a point, are parallel or coincident. Parallel or coincident. I have already told, again I am repeating, question number 2 first bit. Question number 2 first bit. A1 by A2, I mean 5 by 7. B1 by B2, it is minus 4 by 6. Now you can observe A1 by A2 is not equal to B1 by B2. So the system is consistent as the situation is coming. A1 by A2 is not equal to B1 by B2. This is your exercise 3.2, question number 2. First bit. A1 by A2. Write in this way. A1 by A2, it is coming 5 by 7. Then B1 by B2. B1 by B2 is minus 4 by 6. If you simplify, it is coming minus 2 by 3. Minus 2 by 3. Now, A1 by A2 is not equal to B1 by B2. It proves that it has unique solution. The graph intersect each other at a point, then you can get the solution. As per our instruction, on comparing the ratios, find out whether the lines representing the following pair of linear equations intersect at a point, or parallel or coincident. Now you conclude the lines intersect each other at a point. The two lines are intersect each other at a point. First option is correct. First one. Similarly, other two bits you'll do. And the same way, you'll do question number 3. But in question number 3, what is written, you say, on comparing the ratios A1 by A2, B1 by B2, and C1 by C2, find out whether the following pair of linear equations are consistent or inconsistent. Previous question, question number 2, you should see the nature of a graph. Lines are intersecting, or lines are parallel, or lines are coincident. But in question number 3, you will say whether it is consistent or inconsistent. If A1 by A2 not equal B1 by B2 occur, then you say it is consistent. If A1 by A2 equal to B1 by B2 equal to C1 by C2, then it is also consistent. If A1 by A2 equal to B1 by B2 is not equal to C1 by C2, then you will say the system is inconsistent. Inconsistent. This is your instruction of question number 3. Accordingly, you will write. Now, I am doing here question number 3, fourth bit. Question number 3, fourth bit, one bit I am discussing. You will do, all are easy questions. Question number 3 here, fifth bit, fourth bit, IV. Question number 3, IV. Here, A1 by A2. You see the question. A1 by A2. Here I am writing. A1 by A2 is coming 5 by minus 10. 5 by minus 10. If you simplify, it is coming 1 by minus 2. Or you may write, it is same as a minus 1 by 2. Then calculate B1 by B2. B1 by B2. Then calculate B1 by B2. B1 by B2. That B1 by B2 is a minus 3 by 6. Minus 3 by 6. It is your minus 1 by 2. Now A1 by A2 equal to B1 by B2. Minus 1 by 2, here also minus 1 by 2. As they are equal, we must calculate C1 by C2. Now C1 by C2, it is obtained 11 by minus 22. If you simplify, it is 1 by minus 2, it is same as minus 1 by 2. Minus 1 by 2. You see now all the three results are equal. A1 by A2 equal to B1 by B2 equal to C1 by C2. So this implies A1 by A2 equal to B1 by B2 equal to C1 by C2. Means the system has infinitely many solutions. Lines are coincident to each other. The system is consistent. As solution exists, it is consistent. Solution is consistent. Okay, in that way you will try to solve the problems. In question number 4, use the same thing. Which of the following pair of linear equations are consistent or inconsistent? If consistent, solve by graphical method. If consistent, if solution is unique, then you solve by using graph paper. And question of 5, 6, 7, in all these cases, you have to solve the problems and do in your homework copy. If doubt, I will discuss. Today, it's already 47 minutes. Normally, after 45 minutes, sound is not clear. That audio is also fluctuating. So, I will close the class now. Okay, I will close the class now. In WhatsApp, you will give your feedback, and in homework copy you try to do the problems of exercise 3.1 and 3.2. Now I expect thank you from you all. Right, thank you, so that I will take the attendance, how many are present at the end of the class. Okay, just after 2 minutes I will close. Just to write thank you and I will close it. And in WhatsApp you give your feedback whether I'm audible or not. Actually, visibility is not clear. I feel this one. One more thing. Tomorrow onwards, this class is not available after the class is over. It became private video from tomorrow onwards, particularly. So you all should try to attend the class. During class, I am available here. After class, I am not available in net. So tell your friends to attend the class during live. Live session is going on. Thank you. I expect you will do in your homework copy. Thank you all.